What if I told you that Lewis Hamilton's worst qualifying result in more than 360 attempts was not a simple lack of pace, but the direct consequence of something hidden that Ferrari only discovered after the session ended? You saw him finish 20th, but what you did not see was the moment that changed everything. In the middle of the rain, Hamilton hit a track cone during his preparation lap, a moment that looked harmless but carried consequences nobody understood in real time. And when Fred Vasseur inspected the Ferrari SF25 after qualifying, he found signs that the impact may have damaged the underside of the car, destroying floor stability and making Hamilton's final push lap impossible to control in the wet conditions of Las Vegas. Stay right here, because once you hear what Ferrari uncovered beneath the car, and how this single detail rewrites the entire story of Hamilton's disastrous qualifying, you will understand why Las Vegas 2025 has become one of the most shocking weekends of his career. The core problem Ferrari faced in Las Vegas qualifying began long before Hamilton attempted his final flying lap. The rain had created a surface that punished any car unable to generate immediate tire temperature, and the SF25 was one of the most vulnerable machines on the grid in those conditions. Hamilton's opening laps showed a pattern that would define the entire session. The tires fell below their operating window almost instantly, and as the thermal energy collapsed, the aerodynamic platform loosened beneath him. The car skated through corners where stability should have been predictable, and the feedback Hamilton delivered through the radio reflected a growing sense of confusion as he realized that nothing he tried was improving the situation. From that moment onward, the Ferrari suffered a combination of problems that reinforced each other. Low tire temperature reduced front grip, which forced Hamilton to adjust his inputs, which in turn degraded temperature even further. Every attempt to build confidence was destroyed by the next patch of standing water or by the cold air stripping heat from the rubber. Engineers monitoring telemetry saw dramatic oscillations in grip levels and aero load that indicated the car was not only cold but failing to settle into any consistent rhythm. The SF25 felt alive in all the wrong ways, snapping at the rear and washing wide at the front in unpredictable sequences. Then the decisive moment of the session occurred. While preparing for another push lap, visibility reduced by spray made it nearly impossible to identify everything on the track surface. Hamilton struck a cone that had been displaced earlier in the session, an incident that looked minor but carried enormous aerodynamic consequences. Ground effect cars rely on clean, uninterrupted airflow beneath the floor to generate downforce, and even a small obstruction can collapse the entire structure. Hamilton continued the lap, unaware of the potential damage, but his complaints about inconsistent balance and disappearing grip intensified immediately afterward. Once the cone strike entered the equation, the SF25 began behaving in ways Ferrari could not predict. The car became unstable not only in high-speed sections but also in low-speed corners where mechanical grip usually offers some reliability. Engineers saw that ride height fluctuations increased sharply after the cone impact, a sign that airflow beneath the floor had been disturbed. Without proper aerodynamic sealing, the car loses the suction effect that anchors it to the track, especially in wet conditions where mechanical grip is already limited. This meant Hamilton was fighting both the weather and a compromised underbody. By the time Hamilton attempted his final effort, the car was operating far outside any balanced configuration. The tires were cold, the aero platform was inconsistent, and the water accumulation on the surface made every corner a test of instinct rather than technique. He pushed with determination, but the SF25 refused to provide the support required to complete a competitive lap. The rotation felt delayed, the traction felt uneven, and the steering response felt disconnected from the tires. When the lap ended and Hamilton saw himself in 20th place, the shock was shared throughout the paddock. This result was not caused by a penalty or by an external interruption. It was the product of a car unable to function in the conditions. As Ferrari returned to the garage, the focus shifted immediately to understanding how such a dramatic loss of performance could occur. Fred Vasseur ordered an inspection of the underside of the SF25, and the findings intensified the concern. The cone impact appeared to have left traces of contact beneath the floor, raising questions about whether airflow had been compromised throughout the final laps. For a machine as sensitive as the SF25, even minor damage can destroy aerodynamic balance. And this discovery reframed the entire narrative of Hamilton's qualifying disaster. It was not only the rain. It was not only the cold. It was a combination of conditions, instability, and a hidden impact that may have sabotaged his effort without him ever knowing in real time. The engineering challenge that Ferrari faced after Hamilton's qualifying collapse in Las Vegas became one of the most demanding internal investigations of their season. The combination of cold track temperatures, heavy rain, and an aerodynamically sensitive car created a situation where even subtle disturbances could produce dramatic performance loss. The SF-25 relies on uninterrupted airflow beneath the floor to generate downforce, but the wet conditions created instability from the moment Hamilton left the pit lane. Engineers saw that the tires never reached the core temperatures needed to stabilize the aerodynamic platform, which meant the underbody was already in a vulnerable state before any external factor could make it worse. This vulnerability made the cone impact far more significant than it first appeared. When Hamilton struck the displaced cone during his preparation lap, the moment seemed harmless because the contact was brief and the on-board footage did not show any immediate mechanical issue. Yet ground effect cars do not need visible damage to suffer. The airflow beneath the car can be disrupted by small dents, abrasions, or changes in surface geometry. Once Vasseur initiated the post-session inspection, the team noticed signs of contact under the floor that corresponded with the timeline of Hamilton's sudden loss of control. It was not a dramatic breakage but a subtle alteration that could degrade downforce rapidly in wet conditions. Ferrari's telemetry supported this theory. Engineers observed irregularities in ride height behavior that began after the cone strike, suggesting that airflow beneath the car was no longer creating consistent suction. These variations in downforce directly influenced how the SF-25 responded through the corners. Hamilton felt the rear stepping out unpredictably and the front failing to grip on turn-in. In dry conditions, the mechanical grip might have compensated partially, but in heavy rain there was no such safety net. The aerodynamic floor must work flawlessly to control the car, and once that stability was compromised, the SF-25 entered a downward spiral that Hamilton could not correct from inside the cockpit. Another major challenge came from the difficulty of generating heat in the tires during the session. Ferrari's wet weather performance depends on building tire temperature early, but the cold asphalt of Las Vegas drained energy faster than the tires could accumulate it. Each corner forced the tires to fight for grip, and the long straights cooled them even further. This thermal collapse intensified the effects of any aerodynamic disturbance under the car. Once the tires fell below their operating window, the vehicle's balance oscillated uncontrollably. Engineers watching the data stream saw that Hamilton's tires were colder at the end of his final lap than they were at the beginning, an extremely rare behavior in a wet qualifying session. Vasseur's concern increased as the team analyzed the sequence of events. He understood that Hamilton's final position was not the result of a lack of skill or risk-taking. It was a cascade of technical failures amplified by the worst possible conditions. Other teams were able to maintain enough tire temperature to extract some performance, but the SF-25 clearly struggled far more than its rivals. When combined with the airflow disruption created by the cone impact, the car became nearly impossible to handle. Vasseur emphasized that the car had not suffered a mechanical failure. Instead, it had entered a state where all the small weaknesses aligned at the worst moment, producing a dramatic collapse in performance. By the end of the investigation, Ferrari concluded that Hamilton's 20th place was the result of multiple factors acting together rather than a single cause. The rain robbed the tires of heat. The cold asphalt destabilized the aerodynamic platform. The cone strike introduced underbody disturbances that amplified every imbalance. And the SF-25, which relies on precision to function, had no margin to absorb any of these disruptions. This raises a question that every fan must consider. If you were responsible for analyzing a qualifying session where the car behaved unpredictably under extreme conditions, would you focus on the weather, the underbody impact, or the tire behavior as the primary cause, or would you accept that all three formed an unavoidable combination that sealed Hamilton's fate? The consequences of Hamilton's qualifying disaster in Las Vegas extended far beyond the numbers on the timing screen. Ending a session in the 20th position is shocking enough for a driver of his caliber, but the context surrounding this result amplified its impact dramatically. The fact that this was the first time in more than 360 qualifying attempts that Hamilton finished last by pure pace, without penalties or mechanical failure, forced the entire paddock to reassess what had gone wrong. The moment the session ended, the discussion shifted from disappointment to alarm, because such an outcome demanded an explanation that went deeper than simply blaming the rain. The emotional weight of the result was impossible to ignore. Hamilton climbed out of the SF-25 visibly frustrated, not because of the position itself but because the car had given him no tools to fight back. He had spent the session pushing a machine that refused to respond in any predictable way, and when he reviewed his lap times, he saw that the deficit grew larger every time the tires lost heat. He understood immediately that something had broken the connection between the car and the surface. For a driver known for his mastery in wet conditions, this collapse in performance cut deeply, raising questions about how a champion could be placed in such an unmanageable situation. Media reaction arrived within minutes. Analysts across the paddock replayed the qualifying footage and noticed the moment when Hamilton struck the cone in the spray. On first viewing, it looked insignificant, almost invisible in the chaos of the conditions. But once Ferrari confirmed underbody contact during the post-session inspection, the narrative shifted. Observers began to examine whether this impact had undermined the aerodynamic stability of the SF-25 at the worst possible moment. The idea that a loose track object could sabotage a driver's entire session triggered broader criticism about track management, visibility standards, and operational protocols in wet conditions.